Hello, my name is Juraj Michalek, and let me welcome you to our session where we are talking about benefits of development containers and cloud development. And we will be looking at things that can be improved by using these techniques in embedded world. And we'll be talking about just few files that can be added to your project, and you can get really big benefit in development cycle and how the project is developed. So let's imagine three scenarios. First of all, let's imagine the new team member is joining a development team. The first thing that the developer needs to do is to set up the development environment. This can be quite challenging task because the developer needs to install all the tool chain and all the tooling required for the building. First of all, he needs to install Git, then to install the Python and all other dependencies of ESP-IDF. Then the developer needs to make a proper clone on ESP-IDF, and then probably he can start building if everything goes all right. In Espressif, we invested a lot of time to make this experience as smooth as possible, so the developer does not need to wait too much time. We have the Windows installer that is able to deploy drivers and whole tool chain, Git, and so on. For other operating system, we have integrated install script that can do all these things. Yet still, there might be some problems. For example, new version of Linux distribution is not supporting some part of tooling, some linking is broken, or any other issues. So it takes time for developer to be productive. It can be 1 day or 2 days or even more. If it's junior developer, it can be a very challenging task. So that's the first scenario where this cloud development and dev containers can definitely help. Soon we will see the example. Let's consider the second scenario. You have a production code that you and your customer is running, and suddenly the customer experiences a bug. And you need to talk to the customer to debug this issue. And sometimes it's very hard when customer is located in different country that is far, far away. You need to send a developer team there to diagnose the issue or pull a logs from the customer. And the whole process is relatively problematic and time-consuming. And here is a nice example where dev containers and container development in a cloud can save you a lot of trouble, and you can share the same experience or same environment with the customer. This is really handy. We will also see like how we can use a walkway simulator to share the working environment. And the last scenario that we need to consider is a maintenance. For example, your developers created a code that is deployed to production, and then after 2 or 3 years, there is a bug, there is an issue, and you need to fix it. How to do it? This can be rather challenging because you need to reset up the build environment that was done 2 or 3 years ago when the project was in development, and that might not be possible. That might take a lot of time to get to the state where the developers had tooling and the tool chain set up 2 years ago. Even, for example, where developer leaves the company and IT wipes his computer, the whole environment is gone. And this is loss. So let's see how we can do the better approach, how we can use better approach with development containers and cloud development. So let me share a screen with you. So as you can see on the screen, I have here the project that is stored on GitHub. It looks like any other project for embedded development. And this one is written in programming language Rust. You can hear some talks in our conference about the Rust. And in this case, this application is using Rust on top of ESP-IDF. It's relatively complex from the point of view of setting up the development environment. And the project itself is relatively simple. So let's look what this project does. The project is called ESP Clock, and basically here you can see our Rust board with C3 connected to a display. And as you can see from the screenshot, it's just a simple project that displays some time, some information on the screen. The question is how you can run the similar project in your environment. Let me show one interesting thing that is integrated directly to the README of the project, and it's this nice button. Let me click the button for you. And as you can see, it automatically opens Gitpod. Gitpod is a service that creates a container, or let's say whole development environment in the cloud, and it will give us the opportunity to work remotely on our code. So let's wait a second. Now the Gitpod is preparing for us the container image. As you can see, the environment is ready. Here we have the working server that is remotely attached to my web browser, and I can see here a project. So let's run some scripts. And let's try to run this project in Walkway Simulator. So this will take a while to build a project. It's the same if I'm building it locally, but now the whole project is on remote server. So it's not using my local resources. I'm attached to the server just using this web browser. Okay, so build is ready, and let's click at this link. And wait a moment. And we can see that the simulator is running. So as you can see, I was doing no installation local computer. I was building everything online, and now the simulator with the project is running. So this is a great example how the containers can help us in remote development. And you might be asking, how is it done? And let me share with you just a few files that is related to the project and then you need to put into your project. First of all, if you'd like to integrate with Gitpod, which is one of many services outside that can give you this remote development, you just need to put their Gitpod YAML file. In this YAML file, you can specify a few things, for example, which port you operate, and you specify a pointer to so-called Docker file. Docker file is a description or instructions for container daemon to create an environment for you, so-called container. And this one is repeatable. So you can build new container on a base image. In this case, we are using Gitpod base image workspace base. You can put here any Linux distribution that you like, for example, Ubuntu, and then describe here the instructions how to set up the environment. For example, you need to install Python 3, libusb 1.0, or something like that. And then add the installation of the toolchain itself. You see, one simple file can make a big difference. And you may be saying, okay, that's nice, but are there any other alternatives? I don't want to use Gitpod.io. For example, let's say that the organization has account at GitHub. In that case, you are able to use code spaces, which gives you basically the same features like Gitpod.io that I showed you before. But you may say, I don't want to have everything in the cloud. I need some local development. How can I do it? Again, this is relatively simple, and you can use local containers with Docker, Podman, or Lima, or any other container orchestrator. Just install it on your computer, and you can pull the images from internet. You will get the same environment, same definition on your computer. Really nice. So we have 3 ways how to do it. And you may say, okay, you are showing us Rust, but show us ESP-IDF. In this case, we can check this project, CTEC TBD which is extensible open source Eurosrec sound module written by guys from university in Kiel in Germany. And this is open source project and a really nice example of big project that can be built on top of ESP IDF and can run on ESP32. So the project, the physical version looks like this. And let me scroll down. And again, they have here the open in Gitpod button. So let me click the button. It will start a Gitpod for us. It will prepare the working environment. In this case, we will have ESP-IDF installed, just the toolchain required for ESP32. Wonderful. We have here the working environment completely set up with ESP-IDF. We can see also the project here. And now we can use our familiar command idf-py and build. And the builder is started, and we can see the build process in the same way like it's done on the local machine. Very well. We can see successful build. We got the binaries that can be flashed to the chip itself. And this is really nice. We are also able to do the flashing from the web browser on the real chip. So this was a great example how cloud tools can help us to maintain and create a built environment. It's repeatable. That's the biggest advantage of using these meta files. So I will ask my colleague Sergio Gasquez to tell you more about directories like dev containers, which allows you the same integration for Visual Studio Code that you can run locally on your machine. And I would like to ask him to explain more and show you some other examples. So, Sergio, stage is yours.
So thanks for the introduction, Juraj. I'll be following the conversation about dev containers, but this time we'll focus on GitHub code spaces and Visual Studio Code. Those two approaches of dev containers use this .dev container folder for the configuration files. As we can see, we're using the same project, ESP-clock, and we'll have a look at those configuration files. So in this folder, we can find a Docker file and a dev container.json file. Let's have a deeper look into this. Docker file looks just like a regular Docker file, a bunch of arguments based on Debian in this case, a bunch of dependencies being installed. No magic, just a regular Docker file as any other. And in devcontainer.json is where the magic happens. This file tells how to build the Docker file. In this case, we're telling where the Docker file is located and the arguments that we want to use. This is the build property. Let's say that we want to pull an image from Docker Hub or any other Docker registry, container registry, and pull it and use it. We can also comment this build property and use the image property, which will pull the image from the internet. This has the big advantage of the time of the building time. It's way faster to pull it than to build it. But if you want to have the image locally and tweak it, the only way to go is having a local Docker file, which we build. Other than that, we're also setting a bunch of settings for the IDE, and we're also setting some extension to be there. We're also forwarding some ports and specifying where we want to mount the workspace and the workspace folder. So this simple file allows and enables a lot of features that we're just going to see now. So let's go back to the project. And let's say that we want to open it with GitHub Codespaces. In order to have the Codespaces feature enabled, you either need to be part of a GitHub organization that has this feature enabled, or you were part of the beta of this feature. And then if you were part of the beta, this feature will remain enabled for your user. Anyway, you can go into this button code and create a new Codespaces or just run a previous one. In this case, I will run this one. This will set up your Codespaces. What it will do is either pull the image or build it. In my case, it will be faster since I already had it built in the past, so it just runs up the dev container And as we can see, we can now see the README of the project, and here you can see all the files. This is a fully working environment where we can build a project, upload the code to a real target, or simulate with Workby, as we just saw with Juraj. Say that we want to use the very same project with dev containers, but this time in our local machine. How do we do that? Here I have my terminal where I just cloned the very same repo that we were using. Let's jump into the folder and let's open it with VS Code. Visual Studio Code will recognize that there are some dev container configuration files under this folder, and it will ask us if we want to reopen the project in a dev container. Let's do it. Again, the first time that you will do that, it will need to build the Docker file, the container. So it will take a few minutes. In my case, it's already done. It's catch, so it's way faster. Now, again, I'm on the dev container, fully working environment. In just a few minutes, you have everything ready. The only requirements in order to use local dev containers with Visual Studio Code is that you need to have Visual Studio Code installed, an extension called remote containers, and also you will need a container orchestrator, Docker, Podman, or any other. And this is the approach for local dev containers. In here, you can do cargo build, and it will just start building the project with everything ready. Okay, so this is the approach to use dev containers in a project that has already the support for dev containers. Let's say that you want to start a project from scratch. Let's go back to the Chrome. You want to start a project from scratch in this time using Rust, and you want to have dev container support. So the way to go is use one of our templates. For Rust, in ESP chips, we currently have two templates. One of those is ESP-IDF template, which has a standard library support, which because it's based on top of ESP-IDF, and the other one is called ESP template. It's pure Rust, bare metal Rust, no standard library support. Let's use ESP-IDF template to generate a project using Cargo Generate, which is a tool that helps us generate projects based on templates, and this ESP-IDF template is one of those templates. Let's just generate a project and see how we can use the containers. Let's just say Cargo Generate, and here we'll use the URL of the project in GitHub. This will ask us a few questions: project name, the container. And it will ask us if we want to have standard library support. We do want ESP-IDF version. In this case, we'll go for 4.4. And MCU that we want to use. Let's use, for example, ESP32C3. And last, the most important question, if we want to have dev container support, let's say true. Now we'll jump into the folder. Again, when we open it in Visual Studio Code, we'll have the pop-up saying if you want to open it in a dev container. If we miss the pop-up, we can also go here to those arrows and say reopening container, or also use the command palette to ask Visual Studio Code to reopen it in a container. Again, we now have the fully working environment. One previous limitation about using dev containers was flashing devices. This is no longer a limitation since we can use the ESP web tool to flash a real target from our browser. The way that we do that is the same way we simulate our projects on Workby. What we're doing is building a project, generating our binary and the necessary files, and then sharing them via WebSocket to the browser so we can flash or simulate. And this is how we use Visual Studio Code in a project from scratch. Also, it's worth mentioning that Visual Studio Code works on all the three main platforms. So you can have it on Windows, you can have it on Linux, and also on macOS. Also, along with our templates, there's this .vs Code folder, which has some extra features that enable us to have these buttons on the UI, which will help us to build a project, to build on Flash, and to build and run the simulation in Workby. Those three buttons are attached and linked to some tasks, which are telling how to build the product and how to do everything required. The launch.json file is telling Visual Studio Code who to attach to a debugging session run on Walkbee. So you can use Walkbee to debug your project using a JDB, using this DB. And the way to attach it is using this launch.json. So you can just go here, run the Walkbee simulation, and start debugging from Visual Studio Code. This allows for a fully featured working environment that you can run, simulate, and build your product. Last but not least, let's say that you want to do dev containers, but this time, instead of routes, you want to go to the C word. So in ESP-IDF, we have ESP-IDF dev container project, which is basically a dev container version of the Espressif ESP-IDF template. So it's a main and simple project on ESP-IDF, but it has support for Gitpod, for Visual Studio Code dev containers, and also for GitHub code spaces. Let's just open a session on code spaces. Let's open this one. Again, it will set up the environment. This will take a few moments. In my case, it will be faster as I already have created the environment before. And here we have the fully working environment. We're previewing the README. We have all the files, necessary files. And also, it's worth noticing that in this case, we already installed Espressif ESP-IDF extension of VS Code. So we have all the features of built-in alongside the build and flash button and the Walkbee simulation button. So that's everything from my side. Thanks for listening. Enjoy dev containers. And back to you, Juraj.
Thank you, Sergio, for sharing with us all these great examples. As you can see, you can achieve a lot just by adding few files to your project. You can improve the newbie experience if somebody is onboarding to your project and give him a repeatable environment. You can use the same tooling to share with customer the environment and help the customer to debug the product. So that's really nice. And you can use even the same environment in the maintenance mode, where, for example, in 2 or 3 years, you need to set up the same environment. With container files and Docker files, it's easy. You can use either Gitpod, which is cloud service, code spaces from GitHub, or even local development, where you can leverage your own infrastructure using VS Code and the remote container extension. So we are more than happy to share all this information with you, and we are looking forward to see your experience with containers, and we are looking forward to hear about interesting scenarios that you were able to achieve with these cloud technologies that is definitely helping embedded world to get better and better software. Thank you very much.
Wow, really nice talk. And now I'd like to invite Juraj and Sergio to join us for the Q&A session. Hello, guys. How are you?
Hello. I'm doing fine.
Hello. Hi, Pedro. I'm great.
Okay, so the first question we have is, can the Walkbee simulation and web flashing be used without using dev containers?
I can tackle that one. So yeah, we have 2 crates built on Rust. That one is for using Walkbee simulation, which will just create. Once you have the binary, it will share it with Walkbee through our WebSocket, and you will run the full simulation on Walkbee. And another crate also built on Rust, which is pretty much the same, but for web flashing. So once you have the binary, you can share it via a browser to your browser, and from there you can flash it with no problems. Okay, so no dev containers are required.
Okay, Really nice. So I have a question. It's more like related to performance and the benefits of using that container. Like, what can you just like talk about like the benefits of using that container?
Yeah, okay, so I will take this question. Yeah, the containers may help you a lot also in enterprise environment. For example, we see that many customers have like security policies and antivirus in place, which may be incorrectly configured, and it's slowing down the build. And especially ESP-IDF build might take up to 2 hours on some Windows with some special antivirus softwares. In that case, it really makes sense to leverage the development containers and to run the build in the isolated environment in the container, where the build can be like really fast because it's running on Linux kernel, and the build can take about like 1 minute in case of ESP-IDF. You can even put this container or like very powerful servers that often are in enterprises installed already in-house. And in that case, the build can be even speed up using, I don't know, 20 or more cores where the build is parallel, since we are using Ninja CMake, and it can leverage all these things. So it can be really faster using the dev containers.
Okay, really cool. We have next question here, and is there any possibility of downloading those build bin file offline?
So I can answer it. So yeah, from Gitbot, you can download any file, same from GitHub code spaces. And when using local dev containers with VS Code, you can like mount the volume, so you have every file synchronized within the Docker and in your host machine, so you can have the binaries available offline on all the 3 methods of dev containers.
Okay.
If I may, I will also add that if you're running a walkway simulator, there is this hidden functionality behind the F1 button, and you can type a download, and it will provide you the binary that is in the simulator. So that's another option how to get to the binary.
Okay, good. So next question. Where we can create an IDF project in Visual Studio Code, Espressif plugin, automatically create a dev container? Is necessary to do something else to have this functionality?
So I can also answer this one. By default, the Espressif plugin, like the extension of Visual Studio Code, does not add dev container support. We are working towards improving our dev container support, and in the future we may have this functionality, but at the moment the way to go if you want to start a project with ESP-IDF and have dev container support is either you include those files on your own, or we have a working template with ESP-IDF, which we are working also to improve it, which already is a very simple ESP-IDF project with everything set up for dev container support.
Okay, cool. Okay, so thank you for showing us this cool feature today and how to use dev containers. So thank you so much.
Thank you.
Thank you.
Bye.
Bye-bye.